So I'm going to spend 4 minutes, and Stig is then going to tell a little bit about an trial implementation of this that he's been looking at. So external workspaces are a new format for saving workspaces, which allows very efficient loading of functions, variables, etc., whatever's in the workspace, the first time they are used, rather than loading the entire workspace from disk into memory. And the key thing here for a lot of applications is most of what's loaded up front in these very large applications is never used in any particular user session. How do you use them? It's quite simple. There's a couple of I-beams. 8666 is the one for loading. The one for creating I-beams is 8667. So if you have a workspace, you say 8667 I-beam, the file to be written, and you have to give a slot number between 0 and 7. You can only have up to 8 of these loaded at any particular time, and you're actually giving a memory address that they'll be loaded at. You can optionally limit the names that are put into it. If you don't provide the left argument, it's everything that's in the workspace. And when you attach them, you just say 8666 IB and the name of one or more up to 8 of these files. And all the names in the file appear to be in the workspace. So QuadNL will report that they're all there, but they don't actually appear until you use. And if you only run the first 10 lines of a function that's 10 kilobytes long, it will only load, in fact, the first page of things. So the benefits of this, obviously, I think, faster startup. If you have a 100 megabyte workspace, you don't have to load it. In fact, you can have a completely empty workspace, just set QuadLX to attach your external workspace and then run your application. Unused code is never loaded. Even the used code doesn't actually come into your active workspace. It's in a separate part of memory, in a memory mapped file. And if you have multiple processes running on the machine, they will share that file. So if you have 16 processes running the same application, they all just share that one memory mapped file. The first guy who uses it brings it in from disk into memory, and then everybody else doesn't even have to wait for that to happen. They're just using stuff which is already in memory. Some tests have shown that the execution is actually faster because of that. There's more free workspace, the garbage collections are simpler, etc., because these objects which are read-only are simply not there. The limitations, this one will go away, and maybe this one, but the other two are really fundamental because the memory map files are mapped by the processes and appear as their real memory. The files cannot be modified in any way while any process is using them. So if you're going to be developing and updating them, you have to have some generational mechanism for loading several of them. And again, because they're being used as real memory by processes, we can't convert data as you use them. So they cannot be shared across architectures. So that's what the technology... The quick introduction, 5 minutes, maybe 6, to the technology. And I think this is yours.
Yeah, hi. We have been trying this concept. We are not using it production-wise, but we have done some experiments, and then I will tell you a little about what we have seen so far. Very quick introduction to the company I'm hired in, SimCorp. We have been around for quite some years. Have customers worldwide and have subsidiaries there. The things in bold are where we have development done, primarily in Denmark and Kiev. And we have around 300 developers, at least 200 developing APL code. We have currently around 73,000 functions and a lot of lines of APL code. At the customer side, this could be a typical setup. We are a little old-fashioned with regards to installation, so we don't install our product at customer side. You can actually do it, some customers use it, but the normal setup is old client-server setup. You have the system on the server, and you start it up on your clients, and you have a number of client computers, each consuming some memory. Not a big deal, not a huge problem, but even more usual customer setup is to run these the system on Citrix server farms. So suddenly we have our system running several processes on one physical computer. And then the client computers is just very thin clients. And then you could argue that memory starts to make sense to look at. Could we actually do something about this memory consumption, because it's a rather heavy application we are dealing with. Where in SimCorp we have this, of course, the workspace. What we call the main workspace, what we usually load at customer side, contains a number of functions. All our functions are grouped into what we call modules, and each module can be marked as should stay in the main workspace or not. But a number of modular functions on the main workspace, and then we have a lot of variables, but these are not variables. In our mind, it's constants, and we would very much like to have a way to actually mark them as constants. They will never change, but they are nevertheless variables. So in our normal initial workspace, we have around 33,000 functions and over 100,000 variables that are assigned when you load the. And all in all, it takes up 58 megabytes. And when we start up the application, a lot of initialization is done. We create some caches and some variables that contain various information. And once you start up your applications, you can load additional functions to do the more application-specific stuff, while the stuff in this box is general framework mostly. So this is what we are dealing with. So what could we do to try and make this free workspace a little bit bigger? But then we could try out this new concept with external workspace. One approach could be just to take the initial workspace and put it out in an external workspace and then load it via these new I-beams. Another thing could be actually to take all our functions, all 73,000 functions, put it into one major workspace. We sometimes have problems with loading these modules. You have to remember that, okay, if I start this application, I need to remember to load this module, otherwise I will get a value error if the functions are not in the workspace. So this could be a way to actually avoid value errors forever, and a lot of application developers would be happy not to think about modules any longer. As far as I remember, Morten yesterday mentioned that this could be in the pipeline to have some kind of data caches outside the workspace. And the difference between these two concepts is that the external workspace is read-only data. It will not change, or if you change it, you change it inside the workspace. why this is more dynamic data. It could be nice, but this is not something we have now. So if we go for this solution with all our functions in one external workspace and put back our data caches into the free workspace, we can see, as Morten told us, but NL will actually report back that all the functions are there, but they are not loaded into the workspace. They are not even necessarily loaded into memory yet. So this actually works, and and the point is that when we start up a number of sessions and connect to the same external workspace, it is only loaded once and can be reused between a lot of different sessions. So this definitely gives us some benefits. But it is not because of we can go down with a few hundred megabytes on the Citrix server. That is not the only reason for looking at that. This concept is actually nice to have, but it was actually another thing that tricked us to look at this. And because we have been told, you probably all know what this is about, or a lot of you know what this figure should mean. We have been asked to look at this isolate concept, and we are trying to still to see what we can use this for. Of course, we have to do something about. So this is isolate in a Morten vision. You have a isolate here doing a little calculation, then turn and maybe disappear, and things speed up. But this is not how we see it in SimCorp. Because we cannot split up, or the problems we are dealing with is not to have small calculations done. We have to have our entire framework at hand to do anything. So we should think more in worker bees, kind of isolates that will probably have to live forever. But still, if we are going to start up a lot of workspaces. So this is what we're dealing with. It is actually faster. So if we only stick to the main workspace, it loads 15 or 16% faster. If we load all the keep all the functions in one external file, it is 25% slower than the old main workspace. So it's not comparable. Of course, it's apples and bananas, but so this is the price we should pay to have all functions in one external workspace. Second time we load the same on the same machine, it's almost 50% faster because it doesn't have to read the external. And even with the big, with all the functions, it's 13% faster than today. So we could pay a penalty on the first startup, and then we can actually benefit after the two next startups on the same machine. And as said, it's the memory consumption is reduced with 58.0. Yeah. So the benefits are very obvious. You get rid of value errors. You have a smaller memory footprint and faster load and smaller max VS and you name it. That's about it. I don't know if you have any questions.
Well, I have a comment to your previous slide, which just shows that us working on speeding things up is pointless, because then as soon as it's running faster, you just decide to do more, and it actually ends up running slower.
Sorry. It's just because we're trying to use your isolates.